Next example, we want to find the slope of the tangent line, which is dy dx, to the curve negative 3x squared minus 4xy plus y cubed equals negative 90 at the point negative 3 comma negative 3. So first off, we want to find dy dx. To find dy dx, as much as possible, we want to move all the x's to one side and keep all the y's on one side. But the negative 4xy that's together, we can't really separate that. So I'll leave it there, the y cubed. Then I'm going to move the negative 3x squared to the right. So it's going to be positive 3x squared minus 90. Then I'm going to take the derivative with respect to x of each term. So I have d dx of negative 4xy. Then I have d dx of y cubed. I have d dx of 3x squared. And then I have d dx of 90. Now, when I take the d dx of negative 4xy, let's say that this is one term called as a, and this is another term called as b. And here's what we know. When we take the derivative of a product, this equals to a prime b plus b prime a. This is the product rule from chapter 1. So if a is negative 4x, then a prime, the derivative of that is going to be negative 4. So this is going to be negative 4. And then you multiply it by b, which is the second term, and that's going to be y. Plus b prime. So b prime, the derivative of y is just going to be 1. But we're going to be left with the dy dx because remember, you put the y over there, dy dx is left over, and then times a, which is a negative 4x. That takes care of the product. Then we have d dx of 3y cubed, so the 3 comes to the front. This gives us 3y squared. We always put the variable we're differentiating over the dx, so this is going to be dy dx, which means we do have a dy dx left over in this term. On the right side, 2 times 3 is going to be 6x. Dx is 1, so that's going to cancel. Derivative of a constant is 0, so we're not going to worry about that. Now, everything with the dy dx, so this term and this term, stays. The negative 4y goes to the right. So I'm going to rearrange this a little bit. 1 times negative 4x, so we have negative 4x times dy dx plus 3y squared times dy dx. The order of these don't matter. You can put them either way. And if I move the negative 4y to the right, it's going to be 6x plus 4y. Then I'm going to factor out the dy dx. So if I do that, I'm left with negative 4x plus 3y squared equals to 6x plus 4y. Then I'm going to divide everything by the negative 4x plus 3y squared, divide by negative 4x plus 3y squared, and that allows me to get the dy dx by itself. So I'm going to go to this side. I'm going to say that my dy dx, this is equal to 6x plus 4y divided by negative 4x plus 3y to the second power. Dy dx, this is the slope of the tangent line at the point xy. Now we want to find the slope of the tangent line at the point negative 3, so what do? I just plug these in. So I'm going to plug in x equals negative 3, y equals negative 3. That's my x, that's my y. So my dy dx, this will equal to 6 times negative 3 plus 4 times negative 3. X and y happen to be negative 3 in this case, divided by negative 4 times negative 3 plus 3 times negative 3 to the second power. If I simplify the numerator, then my dy dx, this will equal to negative 30. If I simplify the denominator, negative 4 times negative 3, this is 12. Negative 3 squared is 9. 9 times 3 is 27. 27 plus 12 is going to be 39. And if I reduce this by 3, then I get dy dx is equal to negative 10 over 13. Okay, long problem, a lot of work. Next, another long problem. Given the equation below, find dy dx. There's 2 of these. We just need one dy dx. All right, so let's first move the negative 39x to the 8th to the right. Just get the y's on one side as much as possible. So we have 3x to the 26th y plus y to the 10th. If I move this to the right, it's going to give me 39x to the 8th minus 35. Next step, I want to take the ddx of each side. Take the derivative with respect to x. Okay, so now let's find those derivatives. This is a product, so we have to use a product rule when we take the derivative. I'm going to call this a, and I'm going to call this b. So the derivative ddx of ab, and on the exam, if it helps you, like write this down so you have to refer to it. We got a prime b plus b prime a. That is a product rule. So a prime, we want to take the derivative of 3x to the 26. So the 26 is going to multiply to the 3. This gives us 78x to the 25th, and then we multiply that by y. Because we're taking the derivative of x, dx is 1, so we don't have to write anything there. Then we have b prime. So the derivative of y is 1, but we get that dy dx. So we're going to get plus dy dx times a, which is 3x to the 26th. Okay. Then we have ddx of y to the 10th. So the 10 comes to the front. This gives us 10y to the 9th. However, if we put a y here, this is going to give us a dy dx. On the right side, if I multiply 8 times 39, this will give me 312 x to the 7th power. The derivative of a constant is 0, so we can ignore that. Now, whatever doesn't have a dy dx goes to the other side. So this stays and this stays. So on the left side, I have a dy dx times 3x to the 26th plus dy dx times 10y to the 9th. This is going to go to the right, so this is going to give me 312 x to the 7th power minus 78x to the 25th y. And now I can factor out a dy dx. If I do that, I'm left with 3x to the 26th plus 10y to the 9th, and that equals to 312x to the 7th minus 78x to the 25th y. And then I divide both sides by the 3x to the 26th and y to the 9th. So here on the right side, I'm going to say that my dy dx is equal to 312 x to the 7th minus 78 x to the 25th y divided by 3x to the 26th plus 10y to the 9th. All right, that's part A. Part B, find the equation of the tangent line to the curve at 1, 1. So first off, this is the slope of the tangent line. So we want to figure out first, what is the slope m? For that, since my x and y are both 1, I'm going to replace in my slope equation the x's and y's with 1. So we get 312 times 1 to the 7th minus 78 times 1 to the 25th times 1. Makes it kind of convenient because all of these are going to be 1s, divided by 3 times 1 to the 26th plus 10 times 1 to the 9th. So I simplify all of this, and my slope comes out to be 234 divided by 13, which equals to 18. All right, then I'm going to say that my equation is in the form of y equals to mx plus b, and now I know what my m is. My m is equal to 18. To get the slope, I use a slope equation plugged in the x and y. But now I want the line, the slope of the tangent line, so I replace the y with the 1, and I replace the m with an 18, and I replace the x with the 1. So I get 1 equals to 18 plus b. I subtract 18 from both sides, and we get b is equal to negative 17. So my equation is y equals to 18x minus 17. That is the slope of the tangent line. All right, last example. Almost there, you guys. Find the rate of change. Rate of change is the derivative, which is dy dx, of the total profit in dollars with respect to time, where r of x equals 50x minus 0.5x squared, c of x equals 20x plus 9, when x equals 28 and dx dt is equal to 30. So let's figure out what this is all about. First off, I want to find a profit function. So my profit function I know is going to be revenue minus cost. So my revenue function is 50x minus 0.5x squared minus cost, which is 20x plus 9. If I simplify this a little bit, then this gives me negative 0.5x squared plus 30x minus 9. That's my profit function. Now the derivative, now notice what we're taking the derivative. It says derivative with respect to time. So with respect to time, it means we're taking d dt. Okay, so it's a derivative with respect to time. So it's my d dt. So I'm taking the d dt of each term. So the derivative with respect to time, it's going to be like this. I'm going to take d dt of negative 0.5x squared plus d dt of 30x minus d dt of 9. Okay, so let's go ahead and simplify this. If I multiply 2 times negative 5, that's going to be a negative 1. And then just drops down a degree, we get negative 1x. But remember, whatever variable you're taking the derivative of, always put it here. So then I have left a dx dt times negative 1x. Derivative of 30 is just going to be, or 30x is going to be 30. So I have 30, but then if I put an x here, then this is going to give me dx dt times 30. And the derivative of 9 is going to be 0 because that is a constant. So we get this. And this is the derivative. So what do we want to do? We want to find the rate of change when x equals 28 and dx dt is equal to 30. So now we're going to plug this in. Dx dt is equal to 30. So x is changing at a rate of 30 with respect to time. So we're going to replace the dx dt with 30 and replace the x with negative 28. So negative 1 times 28 is negative 28. Dx dt once again is 30. And then here we just have times 30. That's a constant. And if we simplify this, this gives us 60. So remember what we're looking for. We're looking for the rate of change of total profit. So the profit is changing with respect to time. Okay, so this is dp dt. The rate that the profit is changing with respect to time. This equals to 60. So this means that the profit is increasing at a rate of $60 per day.